what happens if I have an acceleration graph and I want to make a velocity graph? Okay, now this is actually a pretty straightforward process because we know, well, what does the acceleration graph tell us?
Okay, the acceleration tells us the rate of change of our velocity.
Right,
so
tells
how
us
much our velocity is changing
what
every
doesn't it
second.
tell us?
I have no idea where it's at because I don't see any position data.
Okay.
I have no idea what direction it is going because you can be going toward and have a positive velocity and vice
Sure.
versa. So I don't know where it's at and I don't know what direction it's moving.
And you don't know.
I guess I don't know what velocity it started at either because
Nope.
I could have a velocity of -1 or +1 and still have an acceleration of 0. So I
Right.
think you need to let me know what the starting velocity is.
So let's say our starting velocity is -1 meters per second.
Okay.
Okay, so we're going to start down here at -1 meters per second. And so this is my time axis right here. That's 0. Okay. And I've got my velocity measured in meters per second. Okay, so we're going to start.
Okay, so if we're starting at
-1.
-1, your acceleration for the first 3 seconds is 0. That means you're moving at a constant -1 meter per
So
second.
nothing changes, right?
Yeah.
All right, so that's a horizontal line.
I'm definitely moving. It's just I'm not accelerating.
Okay, so I can see actually if I started at 3 meters or -1 meters per second and I traveled for 3 seconds, I went 3 meters towards the origin. Okay, I just did the area of that rectangle. Okay, but then what happens?
Okay, now it looks like you started accelerating at a rate of +1 meter per second per second.
Okay, I've accelerated at a rate of +1 meters per second per second. That doesn't mean I'm getting faster. That means my speed is getting more positive, or my velocity is getting more positive. 1 meter per second every second. So I need to go up 3 over 3.
So you could have done it by every second you go up 1, or you could have looked at that area again because
Right.
meter per second times second, that'll give you your change in velocity. So your velocity went up 3, so it went from -1 to +2.
+2. Okay, so I had a direction change right here.
Yeah.
Okay, nothing changed on this graph because acceleration doesn't tell me direction. And then finally,
okay, now my acceleration is -2 meters per second, or it changed
by -4.
-4.
Okay, so I'm going to drop down 1, 2, 3, 4 spaces in 2 seconds. Okay, and so we end up going a little bit faster than we started in the same direction we started. Okay, but that doesn't necessarily always have to be the case because if we just started up here at 1 meter per
Okay, so
second,
+1, it still would have been a horizontal line.
right? And I
Then
still would have got faster by,
+1, so we just would have gone up out of there.
and then we'd have
And
gotten
then
slower
gone
by
4, so
Okay.
we would have ended right at the
0.
velocity of 0.
Okay,
Now it looks like the graph is shaped exactly the same.
exactly the same, but the motions are entirely different, right?
Right.
This says I'm moving away at 1 meter per second, and then I get faster all the way up to 4 meters per second, and then I slow down to rest.
You
But
didn't even have a direction
the entire
change in
time
that one.
I'm moving away. This says I started moving towards the origin at 1 meter per second, slowed down, changed direction, sped up the other direction, then slowed down, changed directions, and sped up the other direction again.
So the
Okay.
first graph we did was a lot more complicated,
yeah.
it seemed like, or the motion was
The
a lot
motion
more
was a lot more complicated. But this acceleration graph doesn't
Wow.
care which way we're
We
going.
got the exact,
doesn't care
we
how
get the
fast
exact
we're
same
going.
acceleration
It's the
graph.
same acceleration either way.
That's pretty cool.